Okay, here is the third introductory video for chapter 9. So in this video we're going to talk about mostly what a p-value is. So statistics we calculate this thing called a p-value. So up front, let's just talk about that some experts think we should get rid of p-values altogether. Others think that we should get rid of null hypothesis significance testing. I want you to be aware of the fact that there is this debate out there. However, these concepts are important to understand because they are so commonly used and they're not going anywhere anytime soon. The debates are beyond the scope of this course, but I'm going to touch on some of them just a little bit. If you take my business analytics course, we'll discuss them in greater detail and some of the alternative options out there. In fact, there's an entire different field called Bayesian statistics. You can take an entire course on it, just like you're taking an entire course right now on these inferential statistics using null hypothesis significance testing, which is what we're talking about in this course. It's what's called a frequentist perspective. So just know that debate is out there. If you hear of Bayesian statistics, it's just a different approach to analyzing data. But this video is not about any of that. It's just talking about p-values because it's a little confusing. So before we can talk about a p-value, we have to understand a null hypothesis and what null hypothesis significance testing is. If you see me write NHST for short, that's null hypothesis significance testing because it's a mouthful to say. Even if I just say hypothesis testing for short, I'm referring to null hypothesis significance testing. Okay, so to explain these concepts clearly, let's go back and use our cell phone battery life example from our previous video. So what we really want to know is if the new battery is better than the old one. That is the average of the new battery. Is it greater than that of the old battery? So we can actually write this out. So if you can't see the screen right now because you're driving or listening to this on your headphones or whatever, that's okay. But what we want to know is 8 hours and 29 minutes greater than 8 hours. So let's just assume that the 8 hours and 29 minutes, remember, is one of the averages from this from the sample that we found. So again, that's a point estimate of the population parameter. So another way of writing this is mu, right? What's mu? That's what we're interested in, the true population parameter, the true average battery life of the new cell phone. So I'm just literally replacing 8 hours and 29 minutes with mu. So this is just a different way of writing this. So this is what we're interested in knowing. Is that value, that mean value, the average cell phone battery life, right, of our new phone, is it greater than 8 hours, right? That's what we want to know, because if it is, then we can advertise that we have a better new phone, right, and that it lasts longer. So that's what we want to know. But of course, right, this is a confusing chapter. That's not what we're actually testing. And this is part of the confusion of NHST, right? We're not really testing what we really want to know. What we're really testing is the null hypothesis, so we'll get to that in a second. So this population, or excuse me, this statement that the population mean mu is greater than 8 hours is known as the alternative hypothesis. So it's labeled as H sub A, right, alternative hypothesis, or H sub 1, meaning H little script 1. Your book, I think, uses HA. I used H1 just because the null hypothesis is H0. So I just keep the numbers the same. So this is the alternative hypothesis right there. So in terms of understanding hypotheses, at least we got one of them down. It's what we really want to know. The null hypothesis, on the other hand, is denoted, like I just said, H sub 0. So the word null means 0 or none. So the null hypothesis represents that there's no difference, there's no effect. So in our example, we would say for a null hypothesis that the new battery is no different or no better than the old battery, right? I know that's a little confusing. Why would you say that? But that is the null hypothesis. The null hypothesis says there's no effect, right? You're coming out with this new product, this new battery. It's no better, right? There's no effect. the effects or the improvements are null, they're 0. So that is our null hypothesis. So H sub 0, mu, the average, the population mean, is less than or equal to 8 hours, It can be even less than, we don't care, we just know that it can't be greater than 8 hours. And that is what we are really testing. This is null hypothesis significance testing. We are testing the null hypothesis and determine its statistical significance. So, what is statistical significance? What does it mean if we say something is statistically significant? So this is actually where p-values come in. So remember the whole point of this video, p-values. So small p-values, just to make things simple, mean that there is some type of effect. Reject the null. So what is a small p-value? Typically, anything less than 0.05 is considered statistically significant. If you find something between 0.05 and 0.10, so it's less than 0.10, but it's in that range of 0.05 to 0.10, sometimes people say that's marginally significant. We'll talk about the exact p-values, 0.01, 0.05, 0.10, but typically it's 0.05 that we're considering. So what is the interpretation of the p-value? What does it really represent? We're going to talk about that, but again, I just want to make sure that it's clear that, we have a null hypothesis, That is what we are really testing. We want to know, all right, well, is this true or not, I want to be careful saying that. We have to be careful with the pedantics of saying something is true, proven, false, those types of things. But this hypothesis, the null hypothesis, this is what we're really testing. And how we test this is with null hypothesis significance testing. And how we do that, how we assess that statement, that null hypothesis, is with a p-value, If our p-value is small, what's small? Generally speaking, less than 0.05. If it is small, we can say reject that null, We have evidence that says that we don't have support for that. So if we have a small p-value, we can reject the null and we can say our results are statistically significant. So again, we have a null hypothesis. We're really testing that null. If we have a small p-value, we can reject it. We can say we have statistically significant results. So what does that mean if we say that we reject the null? Well, basically that would be providing support for our alternative hypothesis. So I think in one of the first videos I said I was talking about transformational leadership. So let's say that we think that it's an effective approach. It's effective in terms that leaders who have that style, that approach, use the skills and behaviors involved in transformational leadership. If they do, their performance is better, followers are better, however you want to define that. We could go out and test this idea, with null hypothesis significant testing. Our null would be that transformational leadership, there's no effect of it. It doesn't affect a leader's performance or followers' performance, It's null. There's no effect of it. So that's what we would actually be testing. So we could go out and collect data, and if we got a p-value of 0.03, and that's less than 0.05, so we could reject the null that says that there's no effect of this style, and basically conclude that, leadership, transformational leadership, is an effective style. That, in the real world, at least in research, is how we use null hypothesis significance testing to come to our conclusions. That's what we do. That's how we use it. But remember, we're really testing that null hypothesis significance testing to find support for it or not. Remember, we're not ever proving anything, So again, these ideas I'm sharing with you are just the big ideas, the big pictures and concepts, so you can understand them. And then again, in the other videos, we're going to fill in the details and more of the specific language. Okay, so again, going back to the p-value, trying to interpret it, what is that p-value really telling us? We know that if it's small, we can reject the null, but really, what does that p-value represent? So, This is where it gets a little confusing. I think it's because it's not intuitive. I don't really know. I'm guessing. But P, right, and p-value means probability. I think hopefully you figured that out, right? P-value is a probability. So we know this p-value represents some type of probability. So here we go. This is what it represents. The buildup, the suspense. I know, you can't wait to hear this. It is the probability of the data given the null hypothesis is true. That's what it means. Right, what does that mean in English, Kristen? What does that mean exactly? So I know it's confusing, but basically this is what we're saying. We're testing that null hypothesis. So right now, we assume it's true. We assume that there's no effect, there's no difference. Why? This is the default. Right, so the p-value, what it's doing is saying, given that the null hypothesis is true, right, given that there is no effect, what are the chances that we would observe the data that we collected? So let's break this down with our battery example. So the null is this. We assume a battery lasts 8 hours or less, right? There is no effect, so this new battery is not going to last longer than 8 hours. So if it doesn't last longer than 8 hours, it's lasting 8 hours or less. So that's our null hypothesis. So right, that just means our new battery is no better than our old battery. So that's the null hypothesis that we're testing, right? That mu is less than or equal to 8 hours. So we go out and we collect our data. Just to make this simple, let's say that we find our average is 9 hours. So clearly 9 is greater than 8. Let's assume we get a big sample size. This is statistically significant. So if we find the average mu is 9 hours, this is overwhelming evidence that does not support the null hypothesis. Remember, the null says the average should be 8 hours or less. But we just found it to be 9 hours, right, on average. So let's go back to the p-value. The p-value is the probability of the data given the null is true. So if we assume the null is true, that the battery lasts 8 hours or less, the probability that we would observe, right, batteries lasting on average 9 hours, right, that's got to be super, super small, right? So again, let me say that. If we assume the null is true, that the average should be 8 hours or less, and we just went out and found out that it lasts 9 hours, right, the probability, right, of observing 9 hours, right, of calculating that mean is super small if the real true value is 8 hours or less, right? That would be so unlikely to find an average of 9, right, when it's really 8 hours or less. So, right, and that's what that p-value is. That's what that p-value represents. So if we said, we went through the whole process and calculated the p-value, which remember we're going to learn about in this chapter, right? If we found our p-value to be 0.01, right, that's according to the standard value of 0.05, like that's 0.01 is less than 0.05, that's statistically significant. We would interpret this p-value as the probability of observing an average of 9 hours, if the true average is 8 hours or less, is only 1%. Right, so there's a 1% chance that we would observe, right, this average that we just calculated of 9 hours if the true population parameter was 8 hours or less. So that's what the p-value tells us. It's the probability of the data, right, of getting the sample statistic basically that you just got if the null hypothesis were true. So in this case, that is, it's super unlikely to observe this average if the null is true. Generally speaking, the p-value really is not going to be 0 because there's a chance that we could observe 9 hours just by chance. So what if by chance, think about this, that we randomly selected the outliers, right, the best of the best batteries? It's unlikely, but it's possible, right? And that's what our p-value tells us. What is the chances of observing the data if the null is true? So a couple last things I want to point out. We do not prove hypotheses, right? Null or alternative, we don't go out and say, hey, we just proved something. We don't do that, right? Because there's all this chance, random sampling, right, that's involved. We cannot say we prove something. We find support or lack of support for our hypotheses. So like I said before, what if by chance we randomly selected the best of the best batteries and found out the average to be 9 hours or even 8.5 hours? We can't go out and say we proved that our new battery is better. We didn't prove it. We just found support that it seems to last longer, right? So you kind of think about it in terms of the legal system. So if someone's on trial for a crime, and there's overwhelming evidence that they committed the crime, right? They didn't like the victim, so they kind of have that reason to commit the crime on them. They don't have a good alibi, right? No one can say where they were during the crime. They have the victim's blood on them, right? Right? This is looking a little sketchy here. There's support that they committed the crime, but we're not proving that they did it, right? And so that's why the jury is asked to make a decision beyond a reasonable doubt. So again, that language, beyond a reasonable doubt, right? We're not proving something. So again, that's why, again, too, the idea of hypothesis significance testing, p-values, null hypothesis testing, it can be a little tricky because it's very pedantic in terms of the language that we use. So please just don't say with your hypotheses, oh, that I proved something, right? You're not proving something. You're finding support for a statement, right? Because we have to consider the fact that there's chance, right? Random, right? Depending on a random sample, right, the results that we get. So I think in summary, we're getting it. The concepts of p-values and all this null hypothesis significance testing, null hypotheses, these are the concepts. They're not well liked by everyone. They're confusing, but they're commonly used, so if you come across it, you should be able to interpret it and understand it. I know my explanations give you a little bit more detail than the Anderson textbook, right? And like I said before, that's not because they're wrong or they're hiding anything. It's just that I'm trying to give you that big picture and more information so that you can better understand and appreciate the concepts. So I hope this is making sense. So from now on, the videos going forward is going to actually show you how to calculate these p-values and how to do them in Excel as well. As always, if these concepts are not clear, please reach out to me, let me know, and we'll try to look at them from a different perspective to make sure that you get these. Thanks.